Alpha Houston on space to ground 1 for Don. We're ready for your downlink.
Okay, I'm going to hit play.
I'm Don Pettit. I was fortunate enough to be science officer on Expedition 6 to the International Space Station. And during this expedition, we had several kinds of science that we did. We did programmatic science, which is well-planned and well-thought-out science, comes up from the ground and is orchestrated from the ground. And then we have science of opportunity. And this is science that is done at the discretion of the scientists on board space station. And this is kind of the discovery science. And during our mission, we called our science of opportunity Saturday morning science. Now we're going to see what happens to a rotating flask of water and bubbles. And this is a flask. It's about 120 millimeters long. It holds 250 milliliters of water, and it's got plane parallel sides separated by about an inch. So you can get a good sideways view into what's happening as this flask is rotating. So let's go ahead and see the fate of these bubbles in a flask that's rotating. Remember what happened inside of the free sphere of water. Contrast that with what you're going to see in this flask. So here we have the flask with the bubbles. We're going to give it a little bit of a rotation and watch what happens. The bubbles rapidly move to the center, just like what we saw in the sphere, and they form this bubble core. But wait, there's more. Look what happened to the fate of these bubbles. They form patterns now. You will have patterns spontaneously form in these little spherical wakes, and then they will disappear, and then they will reform. So you get this oscillating pattern formation. And what's happening here has to do with the boundary conditions set up by having this flask with solid walls and a fluid system inside, and the resulting dynamics drives these patterns. And the patterns will form, they will disappear, and then they will reform. Again, I found this amazing to see these patterns spontaneously form, and then they'll spontaneously disappear. Here we see a flask that's been rotating for a while, and it has a fairly well-developed bubble core. But look at the pattern that's formed. The diffuse edge is the leading edge, and the sharp edge is the trailing edge. And I found this counterintuitive because I'm used to seeing the sharp edge be the leading edge of something with the smoke sort of trailing behind it. So the direction of rotation was just opposite of what I had anticipated when viewing this. If you were to take a freeze frame of that particular object, you would think from an intuitive point of view it would be rotating the other direction. And I found that surprising. And then when you stop the flask, you grab it with your fingers, you can see that the bubble core just rapidly diffuses throughout the volume of the beaker.
And Houston Alpha, that's it for our Saturday morning science.